And in embedded system, we are often told we must choose either deterministic real-time behavior or intelligent AI-driven systems. Today, I want to show you why this trade-off is false. Hello, once again, I am Rasmi, a senior software engineer in ASML. I work in real-time embedded system where missing deadlines are unacceptable, yet intelligent and becoming unavoidable. So let's move on to the next one. So this is called the embedded paradox or embedded AI paradox. Let's start with the core challenges. Limited compute. So that means we cannot have enough power or we cannot have powerful CPUs or GPUs. So embedded system is made for only one task to do. So we cannot have more power. And that too, we have light or tight memory budgets. So we cannot go for a lot of memory because then that becomes more expensive and that is also not easy to handle as well because we want to do limited time things in limited time actually. So that is where the time comes into picture. So a millisecond latency. So anything goes beyond here and a little bit in the time, then time is a biggest problem there. So embedded system is always bound within the time limit. So I can say that millisecond latency requirements like in real-time system, the AI decision that arrives late is a failure. It has to be on time. In traditional AI optimizes for accuracy and throughput. Real-time systems optimize for predictability. Let's move on to the next one. So introduction to RI, introduction to RE AIF. So there was a little bit of hiccups here and there. So REAI gimmick kind of thing. Anyways, so let's go ahead with introduction to once again, REAIF. This challenge led to the decision of REAIF, the real-time embedded AI framework. REAIF is built on a simple principle: AI must adapt the real-time constraint, not break them. So here you can see that a lot of interfaces, like user interface, web client, mobile client, all are trying to access. And this is the biggest thing, like an application server, that is the AI. But everything sits here and that takes the decision where to go and where to grab the data and all that. So it has to happen in the real time. So it provides intelligent functionality without compromising reliability, safety, or responsiveness. The goal is not maximum intelligence. The goal is predictable intelligence. So AI is the biggest factor for AI is not to maximize the intelligence, but we have to be more and more smart actually. Okay, so that we can understand what is going to happen next, what's going to happen next. So ChatGPT, the way it works actually. So similar to that. So next, move on to the next page. Architecture overview. So the real-time AI framework follows the hierarchical design philosophy. The system is organized into three layers, operate in a synchronized control loop. Perception layer, cognition layer, execution layer. So perception layer. The perception layer handles deterministic sensor acquisition and preprocessing. Sensor fusion ensures that all data is time aligned and reliable. So everything has to be in a time based actually. So that's the main thing. And cognition layer, the cognition layer performs AI interface using embedded optimized model, and these models are quantized and hardware accelerated to ensure bounded latency. So the latency is the major factor here. Okay, so the key idea here is coordination without sacrificing determination. So basically, you have to determine what is going to happen next, what might going to happen next. So we need a lot of examples, a lot of models actually, so that it keeps on working on that actually. So the execution layer, as I told you, like it has to be more of jitter free. Every action is scheduled and verified. So next, move on to the next one, which is basically hybrid architecture. When natural questions come to our mind, why not just Python everywhere? Because Python is not, that is one of our favorite languages. Everybody likes that. You just write in English, you are not writing programming language when it comes to Python actually. And it is very easy to write the code in Python and understand the Python and all that. But Python, let me say, Python is an excellent and rapid development and AI workflow, but it is not suitable for a hard real-time system. So I want to give you some kind of example of what is hard real-time system and soft real-time system. Hard real-time system means if something has been meant to be completed in, suppose, in 2 milliseconds, that has to be completed in 2 milliseconds. But soft real-time system means something has scheduled to be reached on time, but if it is gets delayed, that is also fine. Like we have text messages in the phone. Sometimes we send now, but it reaches around 20 minutes later. That's still fine. But in the hard real-time systems, that is not acceptable. So in real-time AI framework, C++ forms a deterministic core. It handles control loops, scheduling, sensor fusion, memory management, and hardware access. Python is used for model development, training pipelines, and analytics. Optimized bindings connect the two with a minimal overhead. The hybrid approach gives us both performance and productivity. As I told you, in C++, we have again sensor fusion pipelines, deterministic, and we have task scheduling, we have process scheduling, we have memory management, we have shared pointers, and nowadays we have C+11, C+13, 17, 23, 26, which makes the C++ also easy to write. I write the code, and it is more secure, safety, and it is more of working towards getting more robust system actually. And whereas Python is always for training the module and data analysis, training pipelines, advanced analytics and visualization, and all those things you can do in Python, and that is also a biggest advantage by using Python. So next slide. So embedded intelligence stack. Let's say making this work requires aggressive optimization. Quantized CNN reduce memory usage by up to 4 times, preserving accuracy. Hardware acceleration using ARM Neon and GPUs provide up to 10 times inference 10 times inference speedups. Compile time scheduling removes runtime uncertainty. Log-free, log-free queues eliminates priority inversion and synchronization bottleneck. So I would like to give you one example of priority inversion. So priority inversion, what does that mean actually? So priority inversion is basically like one task has given highest priority, other task has given lowest priority. So what happens, lowest priority task is doing some work and higher priority task is coming, but it cannot able to take that work because lowest priority is already accessing that particular module or that particular resource. So it cannot able to take what it has supposed to take. So now what to do actually? Now what happens, this highest priority task inherits its priority to low priority task, and then low priority task gets highest priority task, and then it does its job and leaves the resource and gives the task priority to highest priority task again. So that is a bit complex thing, but I hope I could able to make that thing to understand to you guys. Anyways, moving on to the next one. Every optimization exists in one region to protect real-time guarantees. So all this optimization we are doing to protect our real-time guarantees. Move to the next one. So this is energy-aware operation. Performance alone is not enough. Energy matters. So dynamic voltage scaling reduces power consumption during low demand periods. Intelligent hibernation shuts down unused subsystem without impacting wake-up latency. Memory pooling eliminates fragmentation and reduces energy per transaction. This mechanism extends operational endurance without violating time constraint. So the thing is that if something we are not using, like in a computer, we are not using computer, the computer goes into hibernation mode so that it can save the battery. And so in real time also, like something we are not using it for a long time, we can move it to hibernation thing so that we don't have to really reuse the battery actually. Like if you see like Tesla cars or all these battery operated items, they basically have energy saving mechanism actually. Okay, so next move on to the next one. So Missing something? So now moving this one. So it is nothing but our manufacturing applications. So that is nothing but industrial applications. Yes. So in manufacturing environment, real-time AI framework enables real impacts actually. Vision guided precisions, assembly achieves sub-millimeter accuracy with a 99.7 success rate. So if you see now in Google Maps and all, so as soon as you miss one exit, automatically it just within a fraction of seconds or within few seconds, very limited time, it just tracks, how far you went. So you went a different road, so it can reroutes in a different way. So similarly, those kind of things, and in vision guided precision, like nowadays automotive, the cars. So when the cars are going on the road, so they see which is in the front actually. So immediately they take the decision whether I have to go to right or left, or I have to be on my lane or something. So those decisions it has been taken. So those kind of things we can take the advantage of those learnings, and we can proceed. Actually, a real-time inspection increases throughout by 35% while reducing the false positive. So by training our models and all, we can get rid of all these false positive things actually. And predictive maintenance reduces unplanned downtime 60%. Predictive maintenance reduces unplanned downtime by 60% through continuous system health monitoring. This proactive approach optimizes operational efficiency and extend equipment lifespan. So that basically in the downtime, if you're continuously checking the health monitoring, monitoring the health, this could be able to optimize the operational efficiency and extend the equipment lifespan. In the defense applications, so in the defense applications nowadays, everywhere, every country is trying to go beyond, do something extra, do something extra. So in defense environment, reliability is non-negotiable actually. So there, the real hard real-time system comes together. In my previous slides, I told you hard real-time system and soft real-time system. So this is where the hard real-time system comes. Now, if you want to hit somewhere, you have to use that in a real-time embedded system, and you have to be there, and you cannot go somewhere else as well. So the GPS location, it has to be 100% on New York to 99.99%. Okay, anyways, moving on. So real-time AI framework supports autonomous navigation in GPS denied environment through sensor fusion. Swarm coordination emerges from distributed deterministic decision making. Systems were evaluated in contested scenario with dynamic obstacle and bandwidth constraint. Go to the next one. So implementation and deep dive. So C++, this is my favorite topic actually, how to implement, because I'm a developer, so I basically develop the code. And let's see. So yeah, C++ sensor fusion. Loops are to 1 kilohertz with ATF scheduling. So that is one of the scheduling. When it comes to scheduling, we have to be very careful with respect to priority scheduling or phone-driven scheduling and all those things. We have to take care that when threads comes into picture, that is multi-thread data acquisition for concurrent sensor input, adaptive Kalman filtering for state estimations. And then we have inference latency is under 8 milliseconds. Actuator jitter remains below 50 milliseconds. These numbers matters especially for safety certifications. So next is future capabilities. Looking forward, RE, that is real-time AI framework, opens the door to federated learning, neuromorphic hardware, and formal verification. It also enables intelligent workload distribution between edge and cloud. The next one, so key takeaways. So what did we learn from here basically? So let me leave you with 3 takeaways. Deterministic, control, and adaptive AI can coexist. We believe that, right? So next one, embedded optimization makes real-time AI practical. Energy aware design ensures sustainability in field. Okay. And I think I forgot, I missed one. That is production ready blueprint validates across industrial and defense application. AR real-time AI provides a practical framework for next generation autonomous system. And that's all from my end. Thank you so much. And AI, sorry, again, I'm just getting confused with these two words, but anyways, real-time AIF is not just a framework, it's a blueprint for next generation, for the next generation embedded intelligence. Thank you so much.